The Atlantic and Pacific Oceans, two worlds apart. When you look at the map, it may appear like the seas and oceans merge into one another. It appears that there is only one large ocean, with distinct names given to its many regions. You'll be astounded by how distinct the borders between them are. The Pacific-Atlantic Ocean border is like a dividing line between two worlds. It appears as if the two oceans meet at an unseen barrier that prevents them from mixing their waters and flowing into each other. What the hell is going on here? We know there isn't an invisible barrier inside, and water is water. What may possibly obstruct its mixing? Water, on the other hand, might be very different. The Atlantic and Pacific Oceans have differing densities, chemical compositions, salinity levels, and other characteristics. Their hue contrasts clearly, indicating that they are not identical. Ocean climes are the boundaries between two bodies of water that have differing physical and biological features. The most striking haloclines are those that separate waters with various salinities, and this is what we observe when the Atlantic and Pacific Oceans collide. When Jacques Cousteau was deep diving in the Strait of Gibraltar, he discovered this. The layers of salinity varying water appeared to be split by a translucent film, and each layer had its own flora and fauna. When the water in one ocean or sea is at least 5 times saltier than the water in the other, haloclines form. You may make a halocline at home by pouring salt water or colored salty water into a glass and then topping it over with fresh water. The only distinction is that your halocline will be horizontal, whereas the haloclines in the ocean will be vertical. If you recall a few elementary physics concepts, you might argue that a denser liquid should eventually end up lower and a less dense liquid higher. If this were true, the border between the two oceans would appear to be a horizontal line rather than a vertical one, and the difference in salinity between them would become less noticeable as they came closer. So, why doesn't it happen in this country? To begin with, the difference in water density between the two oceans is not significant enough for one to sink while the other rises. Even so, it's enough to keep them apart. Inertia is still another factor. When things move in a system of axes that is moving, one of the inertial forces known as the Coriolis force influences them. To put it another way, the Earth is moving, and all moving objects on it will be influenced by the Coriolis force, causing them to deviate from their intended path. As a result, objects on the Earth's surface vary in clockwise and counterclockwise directions in the northern and southern hemispheres, respectively. The Earth, on the other hand, moves slowly. It takes a day for the globe to complete a full cycle around its axis. That's why the Coriolis effect is only visible over long periods of time, such as with cyclones or ocean currents. As a result, the flow directions in the Atlantic and Pacific seas diverge. It also prevents them from mixing. The strength of molecules connections, or surface tensile strength, is another significant difference between the two oceans' water. The molecules of a substance cling to each other because of their strength. The two oceans have completely different surface tensile strengths, which prevents them from mixing. They could start mixing over time, but because their flows are in different directions, they just don't have the time. We believe that both seas contain only water, but its individual molecules meet for a brief while before being transported away by the ocean flow. But don't you think that the Atlantic and Pacific Oceans are the only ones who don't get along? Many places on the Earth have water that does not mix from two seas or rivers. There are also thermoclines, which are the boundaries between differing temperatures of water, such as the warm Gulf Stream and the much chilly North Atlantic Ocean. Chemoclines are the most incredible of all. These are the boundaries between waterways with varying microclimates and chemical compositions. The Sargasso Sea is the world's largest and best-known chemocline. It's a sea within the Atlantic Ocean with no shores, but it's impossible not to notice. Let's take a look at some of the world's most beautiful climes. Near the Danish city of Skagen, these two seas converge. Because of their distinct densities, the water in them does not mix. The waves of the two oceans collide occasionally, causing foam to form. Despite this, their water gradually mixes, which is why the Baltic Sea is slightly saline. It would have been a vast freshwater lake if the North Sea had not supplied it with water. The Mediterranean Sea and the Atlantic Ocean. Their water does not mix because they meet at the Strait of Gibraltar and have differing densities and salinities. The Atlantic Ocean and the Caribbean Sea. The location where they meet is near the Antilles and appears to have been painted with various colors of blue water. Eleuthera Island in the Bahamas is another area where these two collide. The seawater of the Caribbean is turquoise, while the Atlantic Ocean is dark blue. The Surinam River in the Atlantic Ocean. Near Paramaribo, South America, the Surinam River and the Atlantic Ocean meet. The Uruguay River and its afflux. The Uruguay River and its tributaries meet in Argentina's Misiones province. During wet seasons, one of them is cleansed for use in agriculture, while the other becomes almost red due to loam. The Rio Negro and Solimoes rivers, part of the Amazon River. The Rio Negro and Solimoes rivers meet 6 miles from Manaus, Brazil, but do not mingle for about 2.5 miles. The Rio Negro is dark, while the Solimoes is light, with a different temperature and flow rate. Mosel and Rhine. In Koblenz, Germany, the Mosel and the Rhine meet. The water in the Rhine is lighter, while the Mosel is darker. Ilz, Danube, and Inn. The confluence of the Ilz, Danube, and Inn rivers lies near Passau, Germany. The Ilz is a little mountain river on the left, the Danube is in the center, and Inn is on the right. Although the Inn is wider than the Danube, it nevertheless has its afflux. Alaknanda and Bhagirathi rivers. In India, the Alaknanda and Bhagirathi rivers meet. Bhagirathi is light, while Alaknanda is dark. Irtish and Ulba. In Kazakhstan, the rivers Irtish and Ulba merge near a city whose name you and I will never be able to pronounce. You take a chance on it. Ust-Kamenogorsk. Ulba has hazy water, but Irtish has clear water. The Jialing and Yangtze rivers. In Chongqing, China, the Jialing and Yangtze rivers meet. The Yangtze is brown and the Jialing is clean. Irtish and Om. In Omsk, Russia, the Irtish and Om rivers meet and flow into each other. The Om is pure and transparent, while the Irtish is cloudy. Chuya and Katun rivers. In Russia's Altai Republic, the Chuya and Katun rivers converge. The Chuya's water has a peculiar murky white tint and appears dense and thick here. Katun is a bright, turquoise color. They produce a single two-colored flow that does not mix for a long time as they flow into each other. The Green and Colorado rivers. Canyonlands National Park in Utah, USA, is the meeting point of the Green and Colorado rivers. Colorado is brown, whereas Green is, you guessed it, green. These rivers corridors pass through rocks with varying chemical compositions, which is why they have such a wide range of hues. The Rhone and Arve rivers. In Geneva, Switzerland, the Rhone and Arve rivers meet and merge. The Rhone is a clear river that runs from Geneva's lake, whereas the Arve is foggy since it receives its water from the Chamonix Valley's glaciers. So, what do you think of all this water? Water? Of course, it's a joke, just like so many of my mispronunciations of river names. Give the video a like and share it with a friend if you learned something new today. Here are some more great videos that I hope you'll like. Stay on Could Be Anything channel by clicking to the left or right.